Okay, we're going to kick off the June 16th, 2022 Mare Cognitum virtual chapter meeting of the Moon Society. I'm Ben Smith. I'm the chapter leader, at least for this chapter meeting. This is the last chapter meeting since no one else has stepped up. So agenda, news, volunteer opportunities, presentation, discussion, same as we do normally. So Mare Cognitum is ending. I said I'd do it for a year. It has now been a year. Haven't found anybody interested in taking over as chapter leader, so it will be ending. If anybody in the future wants to take over, I've documented everything that needs to be done step by step. So it'd be very easy for someone to take over. The time commitment is not very excessive. Next, we are putting on our Lunar Development Conference in July 20th and 23rd. It's broken up because we wanted to claim the 20th, that's the Apollo anniversary, and then the 23rd because that's like a Saturday. So hopefully people can attend. It's going to be virtual on Zoom. It's going to be free to members. Non-members that want to attend will need to become members. So we're kind of doing something different this time, streamlining the process. That's the address, the web address if you want to go to the web page and check it out. Everybody attending this chapter is a member, so as long as your membership doesn't expire between now and July 20th, you can attend for free. What we'll do is we'll end up emailing all the members a Zoom link with a password, and that's how you'll get in. It's going to be one track, so you don't have to jump tracks to find out which presentations you want to see. It'll be pretty simple. Right now, we're still putting together speakers and getting the schedule, so that'll be updated as we get the information. We have multiple open seats on our board of directors. The requirement is you've been a member for 1 year and you're willing to stay up to date and participate in our monthly board meetings. So not a lot of duties as assigned, but still very useful, and we need people in the leadership spots. We also have lots of other open positions. The website lists all of them. We're still working on our vision, mission, values, which we've been working on forever because we can't get enough people to actually sit down and want to work on it. So if we can find some people motivated to do it, that'd be great. And as always, Slack is where we do all our communication, so feel free to jump in and say hi. All right.
Are you got to stay active in Moon Society, Ben?
What, to be a leader?
Well,
just board?
To be involved.
Well, I mean, there's levels of involvement. To be on the board of director or an officer, the two requirements are that you've been a member for a year and that you're willing to show up at least 10 out of 12 board meetings. 2 hours, once a month. It's the second Wednesday of every month at like 5 o'clock Pacific time. So we would prefer that, you know, people get more active, help out on projects, even better, lead a project, but do what you can.
Well, I was actually asking about you.
What about me?
Whether you're going to be involved.
Well, I'm treasurer, so that right there takes up a chunk of my time.
Understood.
And
you're also working on an excellent book project.
Yes, I am.
I don't know if you want to talk about it here, but I was pretty impressed with it when I looked it over.
Thanks. Yeah, I'm actually going to scale back some of my volunteer time with Moon Society so I can put more time into Lunar Homestead, which is my company and what I'm working on. And writing the book is one of the primary things I'm working on with that, besides research. And I also want to start creating weekly videos. So don't have enough time to do everything in the world, right?
Hey,
so this slide, this is just some of the stuff we have open positions. You know, we'll take help. It's an all volunteer group, and we can use all the help we can get.
Ben?
Yeah.
When do you think you'll have some detail up as to the Lunar Development Conference? I'm going to be putting out the next issue of Space Watch the last week of June. So I'd like to put a plug in for the conference in that. And I was just on the site and there's no indication yet of any of the programming.
We have no information on programming. We have contracted it out to a third party who is putting it together, and he does not have information on specific speakers yet.
Okay.
So what the website has is all the information that I have, basically the dates, the fee, and how we're going to go about doing, access to it. I know I'm going to be doing a presentation for Lunar Homestead. I haven't quite locked it in, but I'm pretty sure I'm going to do something on oxygen and iron extraction from Mare basalt using a hydrogen reduction process. Specifically from the lens of how would we build such a thing using 100% lunar resources instead of having all that stuff shipped from Earth. That's 98% of what I'm thinking I'm doing. So I know that Nicholas Jarvstrat, who is actually point on the conference, is going to do a presentation. He just bought an old school in Sweden, and he's going to turn it into a lunar analog and research center. So he's going to talk about his process with that. I know he has a couple of people, scientists and people involved in European lunar efforts who are going to speak. And that's all I know at the moment.
I'm also trying to connect him up with a few people who I met at the ISDC. So hopefully at least one or two of them can sort of connect up with him. So that'd be helpful.
Yeah, I know we have enough speakers for at least the 23rd, or sorry, for at least the 20th. Mm-hmm. Michael Lane is the person that we contracted out to put it together. And okay. he ran last year's conference for us. Mm-hmm. And he's got speakers that he's talking to. So I think we'll have plenty of speakers lined up. It's just a matter of he needs to get confirmations and times and then come up with a schedule.
Mm-hmm. Hey, Ben, I'm going to ask a question. It might sound a little bit silly, but has anyone from the society reached out to Elon Musk and offered to build a moon base for him?
Not that I know of.
I think that would be kind of cool. I mean, if he wants to do that with SpaceX, I mean, the society could potentially be a useful resource for him, and probably want to hire a bunch of us.
If you want to put together a proposal, we can definitely think about it.
Yeah, maybe.
So anyway, the website's on this page right here. It's just moonsociety.org conferences ODC 2023. Going over that. Okay, so tonight we are going to have Fredrick Germann. Is that how it is pronounced?
Germann is good.
Okay. He's going to talk to us about his concept of recycling rocket exhaust. So let me stop share and take it away, Fred. And I'm going to mute everybody except for Fred.
Okay. I will explain potential advantages of recycling rocket exhaust into rocket propellant on the moon. Then I will suggest likely difficulties in that recycling. Then I will offer possible means of addressing those difficulties. The propellant on the moon from recycling rocket exhaust will be worth money. Just how much is difficult to figure exactly. Figuring the cost per pound shipped to the moon, starting with the cost of a recent Israeli moon mission, I figure that the cost must be less than $300,000 per pound, because that was the cost of the whole Israeli mission, including the shipping cost. Working from an estimated cost of at least $6,000 per pound for achieving direct lunar transfer orbit, without the cost of developing a payload, I get at least $13,000 per pound for shipping anything to the moon. So the cost of recycling rocket exhaust into propellant would have to be less than that to make it worthwhile. How much less is a good question. If the cost of recycled fuel can be made low enough, it could make transportation from the moon for materials for building space-based solar power stations practical. That's the big draw. Once the facilities for manufacturing space-based solar power are in hand, modifying them to produce space habitats would be a possibility. Solar sails manufactured in the as deployed condition in space to go along with the space habitats is another possibility. That is, if economically successful, recycling rocket exhaust could open the solar system from Mercury to Jupiter to economic exploitation. It is the large demand for materials shipped from the moon for building space-based solar power that makes the problems with recycling rocket exhaust worth looking at to find a solution. Recycling would require rockets horizontally on the surface of the moon instead of launching in the traditional vertical way. The rocket would need to travel about 30 miles downrange within a tube on the surface of the moon for the rocket exhaust to be captured if it accelerates at about 30 meters per second squared on average. The tube would need to be quite straight along the intended trajectory to accommodate the rocket reaching orbital velocity of about 1,680 meters per second. Thermal management would be a concern in capturing hot rocket exhaust and converting it to cold fuel. Tanks of various process fluids, or tanks for the process fluids, would be needed. Building infrastructure for all needs would need to be done without ambient air for internal combustion engines on construction machinery. Lubricants tend to evaporate in the ambient vacuum of the moon, making various bearings difficult to design. But these problems can be looked into. For example, tube, I choose something 12 feet in diameter. A rocket would be sized to maintain about 3 feet away from the tube walls, because the practice of flying aircraft in tight formation on Earth has shown that airplanes can routinely maintain such a distance from one another, and rockets have maneuverability comparable to airplanes. I imagine RFID devices would be embedded in the wall of the tube for sensors in the rocket to determine the position and the velocity as the rocket flies through the tube. A computer would control the maneuvers to maintain the proper position of the rocket in the tube. The rocket tube itself and a considerable array of radiator tubes should be constantly shaded from the sun to help maintain an adequate temperature. This is possible for a tube stretching east and west near the moon's equator by having a shade suspended directly overhead by pillars running with the tube and radiator array in an east-west direction. I propose anchoring propose an anchoring external tube of sintered regolith brick supporting an inner corrugated silicon steel tube for containing the exhaust after the rocket leaves the tube and a door closes. The line of corrugations of the silicon steel would run circumferentially about the tube. So the steel could thermally expand without changing the length of the tube. The support from the anchoring outer tube would allow the tube to change diameter and shape slightly in response to change in temperature while maintaining the same length and position. Ethylene glycol in water would be a good cooling radiator fluid. Other cooling fluids would also be used to help compress and store exhaust awaiting recycling. The final choice of radiator fluid remains for the engineers who fix the specifications. Silicon, iron, regolith, and many other materials are available for building these things on the moon, so only a small percentage of materials needed to build a rocket exhaust recycling system on the moon would need to be imported from Earth. To build all this from lunar materials requires remotely controlled industry on the moon to produce the sintered regolith bricks, glass fiber cables, steel and other metals, grade the foundation of the tube and assemble it. The machines necessary to do this would come from Earth with components of the industrial machinery actually made on the moon wherever that is practical. The remote control from Earth should go on with 3 8-hour shifts of controllers per day. Electrical batteries can power mobile machines, and the batteries could be exchanged, spent for charged at charging stations. That would take care of the lack of internal combustion engines. Mobile machines could walk so that all their bearings could be enclosed in spacesuits that would retain a nitrogen atmosphere and prevent excessive lubricant evaporation. It is hard to put wheels of a wheeled vehicle inside a spacesuit and retain their function. That's why the machines would walk. The outside layer of the spacesuit would not be woven fabric, but plastic film on a smooth surface designed to flex for the necessary motions of the machine. Accordion folds over joints is a possibility. The outer film would wash off with a proper solvent, and the dust that it collects would be separated from the material, and then an outer coating on the spacesuit would be reapplied. The relation of all of this to human spaceflight is that the Enterprise would build a destination that would be worth a human visit, a habitat on the moon with recycling features, shielded from radiation by lunar material, and containing a centrifuge to provide necessary exercise for people who come to do indoor work on the moon. No work for humans wearing spacesuits would be available with this project. This would be a vast enterprise to produce a vast solution of space-based solar power for any people on Earth that will accept it. And I have some questions that I can provide in case none of the audience has questions, that I'm willing to entertain questions.
All right.
I have a really basic couple questions. Maybe I just missed it, but what fuel and oxidizer are you going to be using for this exhaust?
I had planned on methane and oxygen with a ratio of 3 kilograms of oxygen to 1 of methane. That's not enough oxygen to fully burn the methane, but I believe that is the ratio that provides the best specific impulse, about 2,500 meters per second exhaust velocity, if I remember correctly.
Well, I was just wanting to know the raw materials that you were starting out with. The other question I had, you mentioned that you had calculated $13,000 per pound to ship anything to the moon. What cost do you estimate to ship something from the moon back to Earth orbit?
Oh, well, I haven't calculated that cost, but it would involve the recycling of the rocket fuel that is used to lift off from the moon. When the rocket goes through this tube, it leaves its rocket exhaust behind, and that is what is used to produce more methane and oxygen. And the process for producing methane and oxygen from the carbon dioxide of the rocket exhaust would be a Sabatier process, also known as the Fischer-Tropsch reactions. And it converts the rocket exhaust to methane and water. You get carbon dioxide and carbon monoxide. You add hydrogen at a high temperature with a catalyst, and what you get out is methane and water. The methane is rocket fuel, and the water you can process with electrolysis to get the hydrogen and oxygen. There you got it. Your rocket fuel is restored, and the cost of doing this would largely affect the cost of lifting things off the moon to get materials for the building of space-based solar power stations. It's something that's difficult to figure out. That's why I'm leaving it to the experts.
Right. Yeah, I see this as a concept that would compete directly with a mass driver. You know, you're talking about a very large construct that should substantially reduce the launch cost from the moon. It's not a near-term thing, but it's something you would build out, like you said, if you were going to launch a lot of mass from the moon into cislunar space, especially to build out a solar power satellite. So it'd be interesting to somebody to do like a trade study, to head-to-head comparison of this concept with a mass driver.
Yes, I am a fan of mass drivers on the moon to accelerate cargo to orbit also. But I have noticed that some portions of the plan have not been finally established with such specificity that they could be actually put into a blueprint.
Oh yeah, I mean, most of the technology hasn't been built for that.
A problem with the mass drivers sending kilogram chunks to the L4 or L5 positions, which I think they were sending it to L5, is that the moon wobbles in its orbit as it is seen from the position of the center of the Earth looking at the moon. You get different portions of the face of the moon revealed because of this wobbling. And this would also affect the direction that the mass driver is pointing, causing it to need some kind of adjustment of the acceleration of the chunks of stuff sent out to hit one spot. And
you're talking about vibration?
Libration, yes, I believe that's the technical term that's used. And the collector for the chunks of mass that are sent out to L5 was referred to as a conical collector, but the specification was not such that I was confident that it was an exact thing was described. So I think the technology that we need to build rocket exhaust recycling is more definitely in hand. I have not seen yet any mass driver demonstrated with the speed of putting out chunks of mass equal to the escape velocity of the moon, which is approximately what you need to get your chunks to L5. I have seen one description of an electric accelerator of mass that got up to the escape velocity of the moon, but the whole thing had to be rebuilt for another shot. So it doesn't seem to have been actually demonstrated that you could shoot out chunks at 1 a second.
Yeah.
Why don't you just use hydrogen and oxygen as your rocket fuel?
Yeah, yes, you can use hydrogen and oxygen as a rocket fuel. If you'd use methane, you have a somewhat a lower temperature to deal with, and the temperature of the rocket exhaust is somewhat of a problem as far as handling the exhaust to recycle it. So it would perhaps make it more difficult if you had a hydrogen and oxygen as rocket fuel, but it should theoretically be recyclable in its way. You just use electrolysis to recycle the steam into rocket fuel, but it would be a slightly different handling problem.
Well, and you'd also have to deal with the increased difficulty of dealing with the cryogenic hydrogen as opposed to methane.
Well, that's a point also. I think there is some move to using methane and oxygen rather than hydrogen and oxygen for rockets to send things to the moon and to other spaces, because the temperature of methane and liquid oxygen is such that you could have both methane and liquid oxygen as liquids at the same temperature with the proper pressure.
Right. So Nick asked in chat, how do you recapture unburned methane and water vapor from the sides of the tube?
From the sides of the tube? Well, a gas tends to expand to fill every spot within the tube. And so if you extract gas from any spot along the tube, you will get the gas from the rest of the tube to converge on the spot where you're draining it away.
You just need multiple gas pumps to basically create a vacuum inside the tube, suck out the exhaust.
Yeah,
So
you would use vacuum pumps, and I expect you couldn't get it all. So there would be some loss. I think it'd probably be able to get 95% of the exhaust out with vacuum tubes. The thermal management would be a big problem. Once you get the temperature down to a manageable level, you can pump out the exhaust.
So I'm sorry, I keep misunderstanding the idea. So the way that you describe the launcher with payload, and it's launching in this tube, and it's not touching the sides of the tube, it's you know, it's gimbling its motor, so it's going in this exact trajectory, which is great, no problem. The fumes from the rocket, in order to give the rocket that kind of propulsion, they have significant momentum in the opposite direction. So it seemed to me that what I mistakenly thought you were saying was that in the place where the rocket launches from, that there would be chambers or plumbing or something there, and the rocket exhaust would, you know, like all that rocket exhaust in this tube is going to have very strong initial momentum backwards towards where it was launched from. So it seems like that would be the obvious place to try to capture as much of of those, you know, rocket exhaust
I would
as
imagine,
possible.
yeah, I
Right.
would imagine that you would capture the bulk of the exhaust during the initial couple of seconds, whereas, you know, any rocket expends a significant amount of its fuel or its reaction mass just starting to overcome inertia and getting up to speed. So yeah, the first, I don't know, 200 meters of the tube, you'll pick up 90% of your rocket exhaust. But then as it continues to burn for however many seconds that it does, you'll still want to pick up that exhaust. So yeah, I think imagine that most of your vacuum pumping would be close to the ignition spot. And then you'd have points along the way to pick up the rest.
So the problem, of course, is when the vehicle leaves the end of your cannon, because as soon as it leaves the end of the cannon, and you know, the very lightweight, you know, vapor particles, they have a lot of velocity backwards, but they it'd be very interesting to see how exactly that would behave in a vacuum. Except that, you know, like you said, it wouldn't actually be a vacuum inside that tube, because it would be filling so rapidly with exhaust. But as soon as the vehicle leaves the end of that tube, which is open to vacuum, all of a sudden, you know, you have that vacuum there, and so there would be that vacuum pressure.
Would tend to rush out. That's why you close the door after the rocket leaves the tube.
I mean, they have quick open and close door technology right now. So all you'd have to do is open it real quick, rocket gets out, slam it shut. You lose some, but it's going to be minuscule. At that point, you know, most of the mass of the reaction mass is down further in the tube, away from where that opening is. So you'll have some loss, but, you know, I think you'd probably be able to capture almost all of the exhaust.
So you actually wouldn't want it to be too cold, though, because then ice would form on the inside of your cannon. So in other words, you like temperature regulation would be tricky. Like you don't want it to get too cold. You would want that launch tube to remain at a certain heat, so that, I don't know. Yeah, this seems awfully tricky.
Well, that's why I see it. Oh, sorry, Fred, go on.
The initial problem with temperature management would be that a rocket exhaust comes out at a very high temperature. And there's one point that we're missing here that I didn't have a space to put in my presentation, is that when this rocket exhaust, when the rocket starts in the tube, it would start with an electric accelerator, like they use on aircraft carriers. And the reason for this is when the rocket launches vertically, you don't need any adjustment to the ullage. The gravity gives you ullage to have the fuel directed toward the pump, and you can get the rocket to operate properly. But to get it to launch horizontally, you need the electrical acceleration for the first 4% of your velocity in order to get ullage for your rocket, and to have it moving down the tube so that the rocket exhaust, when it starts, isn't overly erosive.
Yeah, there's no froth in the.
So
Yeah.
a mass driver is your first stage.
Or a
not a
or a
mass
magnetic
driver.
catapult.
Yeah, no, I mean, you can call it something else, but I think Irving's right. And, you know, it occurs to me that this would be a great way to sort of bootstrap your way up to having, like, one of the, in the old SSI studies out of Princeton, one of the sort of long poles in the tent of building those mass drivers was building the power generation. Um, and, if you can carpet a significant portion of the lunar surface in very cheaply, in situ manufactured solar panels, then I suppose you're okay. But but there are some drawbacks to that too. So while you're building, while you're developing your capacity, like if you can make the launch tube first, the way that you've described it, while you're building your capacity to manufacture the magnetic coils on the moon and building your capacity to generate a lot of electrical power on the moon, um, you know, you could, you could start it this way that you're describing, and then just as you go along, just add more coil sections, bit by bit, until eventually you scale up to having that same launch tube now now it's a uh, fully magnetic, and you can still launch those same rockets, but they don't have to actually start their engines. Like you can launch a fully fueled rocket from the moon and send it to an L5 place, fully fueled and ready to do its own maneuvers. It seems to me like that might be appealing. I don't know. There could be problems with that. Obviously, I just thought of it, and you've been working on this for a long time. So,
Interesting
what do you
idea.
think of that idea? Is that something that you've explored
Well,
already?
I think that the reason that the mass drivers that were proposed chose a 1 kilometer chunk is because with just 1 kilometer, with 1 kilogram, with just 1 kilogram chunk of mass, the power required for launching to escape velocity is reasonable. But if you have something that can take 1.5 tons of cargo, then the power required is it's 1,500 times more than they were considering with their 1 kilogram at a time acceleration.
But that's what you have on an aircraft carrier catapult.
Yes, the aircraft carrier catapult is exactly what I was saying would be the type of thing that would be used to start out the rocket in the tube with about 4% of the mission delta V, and a catapult would provide ullage for the rocket engine and also give it some speed so that the exhaust of the rocket engine would not be directed at just one spot, that it would wear it away like a blowtorch. So it would spread the rocket exhaust out in the tube to make it less erosive. And
Makes
also
sense.
you could have a larger section of the tube behind the exact launching point to gather some of that initial a high rate of exhaust per foot of tube traveled. As you go down the tube with a rocket that you're launching, the number of pounds of rocket fuel that are dispensed per meter traveled down the tube gets less and less as the exhaust gets spread out over a larger portion of the launching tube per second.
Cool.
The question I have, what public and private space and other organizations have you presented your proposal to, and what's been the feedback so far?
The feedback so far from the place that I put in the idea was that they did not present any arguments against it. Apparently, they either didn't think it was important, or it was an old comment thread, or else they didn't know of any arguments to give against it. I have put the idea mainly on Moon Society website of the Lunarpedia.
So this could be the first presentation on this concept.
This is the first presentation in which some of the things that I've mentioned were discussed. So I was starting out to try to avoid throwing away rocket exhaust by having things launched into orbit from the moon with a rocket sled. And I noted that there was a rocket sled that went up to about the escape velocity of the moon. But the way they had the sled riding the rails was probably something that couldn't be done for putting out cargo in an economical way. And there are problems with a rocket sled, because if you have a magnetic levitation, for example, you come within centimeters of a magnetic support, and a very minor undulation, just moving a few centimeters as the tube extends miles down, would be a bump that you could run in like a hammer hitting the vehicle, because that's the speed with which a shallow bump is met makes a big difference in how the bump is felt.
Fredrick,
Yes.
I think your purpose of doing this was basically to save on propellant, sort of a scarce resource on the moon, correct?
Absolutely.
I'm wondering about the idea of using like an aluminum-based propellant, given that like 7% of the moon is aluminum, something that's very abundant. And I don't know if you could do that directly with oxygen, and 42% of the moon is oxygen. So it'd be such a way that stuff would just, the waste would just come back down to the moon, and you'd scoop it up in 200 years time and turn it back into propellant.
Well, that's an idea, and I have actually seen a still image from a video of a aluminum oxygen rocket being tested. It was being tested in a laboratory condition, and the things like pumping the oxygen and pumping the liquid aluminum into the combustion chamber were done by laboratory equipment, not by actual functioning rocket. So they the idea has been tested, but the development is something that I'm unsure of if they would ever get it done for a practical rocket which would lift off the moon. It's something I'd like to see.
I feel like that would be something that the people living on the moon would want to develop so that all of their water resources don't get sopped off and thrown into space over time. It'd be like a sustainable, trying to preserve, the scarce resources that are there, sort of thing.
Yes, well, recycling rocket exhaust would mean that there would be less rocket fuel used up than if you didn't recycle rocket exhaust. If you only lose 5%, which I think is more than would be lost, then you have 20 times more cargo that would be launched for any amount of rocket fuel that gets used up. Let's see, what other questions do I have? Oh, the steel that I suggested. Why is silicon steel used? Because you don't find much carbon on the moon, so you would use silicon steel in the construction of the recycling rocket exhaust tube. And why would the steel tube be corrugated? Well, that is a something that I have a visual aid for. There's corrugations of the tube there. That's the corrugations of the tubes running circumferentially around the tube would hold the tube in one spot, and it would be supported by a sintered brick tube that would hold it. And the if you take a cross section of the tube, cutting so that you're looking east and west, and this is a cross section, you would have your corrugated steel tube would look like a ring. And if it expanded because of the temperature change and holding hot rocket exhaust, you could get the tube to expand outward to the side and accommodate the expansion due to temperature change. So it's something you have to consider. I don't know how to specify exactly what would have to be done, but something would probably need to be done to ensure that the tube didn't buckle from compression as it got warmer and would tend to expand lengthwise.
Right. Yeah, I like that. That's a clever solution.
Well, let's see. Do I have any other questions here?
I'm still curious about the pressure buildup inside this launch tube. I mean, that's a lot of pressure all at once, even after the rocket has already gotten going. And if there's no, could you describe to us the like, is there like a flame trench? I mean, the lunar analogy of a flame trench, so that when the rocket, I mean, it gets its, its electric slingshot boost at first. I get it, but then that rocket launches, lights off, and the space in the tube between that bell and the launch mount is suddenly going to be really dramatically pressurized. Not in the same way that it would be if this was an actual gun and you're just shooting a projectile. I understand, but it's going to be really dramatically pressurized, and maybe that will help give the payload a little bit more impetus. I'm not actually worried about the craft itself, being cooked, because that's something that you would figure out, you just engineer for. But like the general design, like I guess I'm assuming that you have a way for that pressure to be vented backwards, right? Because it's not actually, none of that pressure is needed to get the payload moving forward. It is its own rocket. This is just the exhaust. So is there a way of venting that backwards and capturing all that exhaust somehow, cooling it quickly? Or
Yes,
maybe you said that already and I just didn't get it.
the tube would extend backward from the launch point as well as forward. And the reason it extends backward from the launch point is exactly for the purpose that you mentioned, to collect the exhaust, like the flame trench directs the exhaust on Earth, except you're directing the exhaust to a place where it would be kept, not thrown away. And you need a larger diameter tube right at the start, because the rocket it is producing a lot of gas per meter that it's moving down the tube at first. And so there has to be room for it near the launch part, a larger and extensive tube, in order to hold the initial amount of exhaust from launching the rocket.
It doesn't
But
necessarily have to
the
be a
tube
It
starts
just
off in
has
a
to be
vacuum.
Yeah,
Sorry,
it
go
doesn't,
ahead.
it doesn't have to be a tube. It just has to be a large volume to collect it, right?
Yes,
You could
exactly.
actually have a sphere tucked in at the back of that tube, as long as it's a large enough volume to collect that gas.
Correct.
Okay, good.
I
That's
think
what I was
that a tube would be easier to build than a sphere, but if a sphere is found to be most convenient, I wouldn't object to it.
Right. It's not the geometry, though, that makes the difference. It's just the volume.
Yes, yes.
That's
So,
great.
James asked, what about the accumulated gases that occur before the rocket?
before the rocket would try to stay in front of the exhaust gases. You don't want gases in front of the rocket. You don't want the rocket moving through its own gases.
Right.
You
Slow
do
it
as
down.
much as you can to avoid that.
Yeah. So you just
And the tube
engineer
starts out. The tube starts out in a vacuum.
Yes, the
Okay.
tube is starting as in a vacuum to start with. And there's another question is, can the exhaust recycling only be done on the moon? And that is, no, not just the moon. It could also be done on a fuel depot orbiting the moon, so that you could get the exhaust from a rocket that decelerates from orbit around the moon to come back to the moon. And it would leave behind its exhaust by the fuel depot, where it would also be recycled into rocket fuel. So you could go back and forth and use the same fuel over and over again.
That makes an interesting transportation architecture.
I think I missed that. I'm sorry. I was writing notes about something else that you had said. So are you explaining how to do this same kind of thing, but from launch from the Earth's surface?
No, from orbit.
No.
Oh no. Okay.
So something in orbit.
Oh yeah. Great. Okay.
So you could have your rocket launched from the launch tube on the moon have a destination of a fuel depot in orbit. And then it would leave off cargo and take on fuel and come back to the moon with a different cargo destined for the moon. And it would leave behind its exhaust at the fuel depot, which would be recycled into fuel again. So it could go back and forth with the exhaust recycled into fuel at both places, using the same fuel over and over again.
So you're using compressors and vacuum pumps to like, once the payload is launched, the door closes at the end of the muzzle, boom. Now you've got this long, possibly oddly shaped volume that's pressurized with exhaust gases. So now that you've closed it off and it does actually have, gas pressure, you can use regular compressors and vacuum pumps to to get the vapors and stuff back out, and then you insert chemistry magic here. Is that what you're thinking?
That's exactly correct.
Interesting.
You would use vacuum pumps to empty the launch tube after the rocket fills it with exhaust.
It'd be a hell of a vacuum pump. And you were saying earlier that there would be many of them along the length of the tube, right? Or at least several of them.
I don't know how many vacuum pumps would be needed. If you drain the gas away at any point along the tube, the gas would rush from any other point into the tube to fill the place where it's being drained away. So more than one vacuum pump is something that sounds reasonable, but
not necessary.
not absolutely necessary. I don't know what number of vacuum pumps would actually be used.
Where are you imagining the vacuum pumps would be? Like right there at the launch base, right? Or someplace
Near
else?
the launching point would be a likely place to have the major vacuum pump for emptying the tube, because that's where you would have the rocket refueled the next time you start a rocket launching in that tube. So the launch point is where most equipment would be concentrated. Of course, you don't want to completely neglect the door. If it falls off, the whole thing wouldn't work.
Right.
It might also be
I have to join another Zoom session that's starting in 1 minute. So thanks so much. It was a very exciting presentation. Really enjoyed it.
Thanks for
Glad
showing
you
up.
could be here, Jim.
Thank you.
All right. Hey, Fred, did you ever think about maybe it might be more efficient to be able to section off the tube and then pump out a section at a time instead of trying to draw everything along that long tube back to the point of origin?
To have more than one door, so you could take advantage of a higher pressure at the start to get your gas out right away.
You might be able to capture more of it if you just section it off and have a vacuum pump for each section.
That's a possibility.
And the vacuum pumps could even be graded, actually, because the ones closer to the muzzle, those are going to be they're going to have very little pressure to work with. But the ones closer to the launch point, they could be very high speed, high pressure vacuum pumps. So you can very quickly, get recover as much of it as possible, as quickly as possible right there while it's still high pressure. I think that's a great idea, Ben.
You might even just section off that end near the barrel just as a write-off. It's too diffuse to even try to pump that out.
But then I mean that implies, judging from what Fred was saying earlier in the discussion, you could just end the barrel there then. If you do make it a certain length and then you're like, oh, I can imagine absolutely what you're saying happening, but one of the reasons for it would be, what if the door at the end of the muzzle fails? Then the whole thing fails. So if you figure out, well, where do we want that secondary door or a third door, so that as that rocket is leaving, we just close the doors behind it, thump, thump, thump. And then if the outside one fails, the whole project isn't dead in the water. We can still recover gases.
Yeah, you'd have to design the doors so that the failure mode is open. So if there's a failure in the door, they lock open instead of locking closed.
The thing destroys it.
Right, yeah. Which means that instead of destroying your craft, you just lost that gas, which is
you lost that fuel.
But yeah, you're right. I mean, you could just say that, At some point, the gas is too diffuse to try to recover. So we're going to put the door there and it's going to slam shut and the rocket is still going to continue to burn for X amount of seconds, accelerating. We're not going to capture that gas because it's just not worth it at that point.
Mm-hmm. Yeah.
Or you make it so that the tube is longer than the rocket burn, so that the craft exit the tube without any burn, the door slams shut and you've captured all of it. And then you do a sequential pump to try to pump it all out.
Someone at some time should figure out how much it costs to pump out the last bit of rocket exhaust down to 1/1000th of a pound per square inch.
1/1000th of a bar, of a millibar or whatever.
I'm sure somebody will do that. They'll be like, it costs this much energy and time and wear and tear on our equipment to gather this much exhaust. And at some point there's a break even, and that's where they'll stop.
And they'll decide what to actually build.
Yep.
But
Yeah.
as far as what was said earlier about getting the exhaust out at a high rate of speed immediately, there is a problem with taking the exhaust immediately at a high speed because it's also at a high temperature. You have a thermal adjustment problem. You have to cool and compress the gas, and cooling is important. So just maintaining the high pressure to get the gas out easily is not necessarily what you want to do.
So do you think that maybe you'll need to have cooling fins running along the length of your tube?
You will
Yeah, he was
have,
describing that. Yeah, the
I mean,
radiators and all
that
that.
would look pretty cool. Let's be honest. I mean, whether efficient or not, it would look pretty neat.
there needs to be definitely radiators to get rid of the heat. There might also need to be shades to protect the tube and the radiator area from the cold of night, so that when it gets awful cold on the moon at night, and if you have some kind of shade blocking the cooling from the area, then you can maintain a sufficient temperature so that your radiator fluid doesn't freeze. That would be something you would want to avoid. If you have water and ethanol for your radiator fluid, it stays liquid down to quite a cool temperature, but not down to absolute zero. I don't know how cold it gets on the moon. I've read how cold it gets on the moon, but I don't remember. And you might not be able to withstand that temperature with the percentage of ethylene glycol in water that you have.
Right. Dana said something about can do the equivalent of running a swap down the tube to bring the exhaust into the pump.
That's a great idea. I think it's a great idea.
So basically what he's talking about, I think, is you have a plug that compresses the volume.
Yeah, starts at the muzzle and travels back towards the launch platform.
Behind it is the vacuum, and it just compresses the gas down towards your pump.
But it's not a smooth walled tube, it's a corrugated steel tube. The reason for the corrugations is for the steel to not expand lengthwise when it gets warm. So it
has an accordion effect.
To push the gas through the tube. So that might not work.
Maybe if it was a flexible material, maybe. Yeah.
Guys, I need to duck out. I'm sorry.
Yep.
But this has been fascinating, Fred. I was very skeptical when you first explained your idea, just very super briefly, but hearing all these details, I am fascinated now. And this would be a really fun thing to come up with a test case. And my last one is, I'm just going to drop this in the chat. It seems to me like this does not have to be perfectly efficient in order to be worth doing. It would be very interesting to see how inefficient it could be and still be worth doing. I don't know. And after it's built, as it's being used over and over again, like once it exists, there are going to be significant incentives to make it more and more efficient,
Sure.
and make the pumps more efficient, and add a second door, and maybe figure out a way to create a swab. How efficient does the swab need to be in order to work? Maybe not very. Maybe it can just go pop, 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 pop. Maybe it doesn't need a perfect fit. Or I don't know. It would just be interesting to figure this out. So, yeah, thank you, Irvin. I agree. I'm not thinking about the pushing of the craft. I'm thinking about how do we like rocket exhaust. I mean, rocket fuel is actually not the most expensive thing, but if we can save a significant amount of it without without you know without spending all that money in a different way, trying to save it. You know what I'm saying? Like if we can do it efficiently, it'd just be very interesting to see all this worked out. And I guess I'm just saying I can see this totally working and being worthwhile without needing to be super crazy high tolerance efficient. It could, I don't know, it'd be very interesting to see some engineering models and some analysis of this. But if you make it at a low to medium efficiency and it actually exists on the moon and other people also exist on the moon, there's going to be a high incentive to gradually upgrade it and make it more and more efficient and make it more and more of a benefit to whatever lunar activities we're doing. So I'm fascinated, but yeah, sorry, I gotta go. Thanks everybody. Woohoo!
Hi.
I'll watch the video later.
Hey guys, I'm gonna duck out too. Have a good one.
Yep. Take it easy, Ryan.
Bye-bye.
One comment about the rocket exhaust and rocket fuel not being the most expensive thing, and that is a Earth-centered idea. On Earth, rocket fuel is not expensive, but on the moon, it had to be shipped there from the Earth, so it is worth thousands of dollars a pound because you have to put in thousands of dollars per pound to get it there.
Yeah, well, exactly. I mean, the oxygen is basically free on the moon, but yeah, it's going to be your methane or it's going to be your hydrogen. That's going to be your cost.
Well, you wouldn't throw away the oxygen after you got it because the oxygen wouldn't be actually free on the moon. There's lots of it, but you'd have to do work to chemically extract it. So
yeah, but
if you chemically extract the methane and you have the rocket the oxygen left over, it's just like extracting metals and having the oxygen left over. It's the oxygen left over from your process that you don't throw away if you have any use for it.
well, that's just the thing. You only need so much oxygen for life support. You only need so much oxygen for your industrial processes. At some point, if you're processing a lot of materials, you're probably overproducing oxygen.
And you throw it away.
You throw it away. I mean, because what are you going to do? Create more storage for a product that you don't need, unless you find a way to turn it into fuel and you sell, or as an oxidizer, and then you sell that oxidizer.
Well, if you'd have enough electricity, you could have a couple of rails going down a path like the tube goes down a path for launching a rocket. But these rails could be charged to a high voltage, and then you would use that to power an electrical oxygen rocket, in which the oxygen goes into a heating chamber, which it's heated by a spark gap going through it from the high electric potential on the rail on the right and the rail on the left.
Like the subway?
Well, I would consider it a surface craft.
I was talking about the electric rail.
Okay. Oh, like the electric rail in the subway. I see. But this would be dangerous if people came into contact with it. But there are no people to walk onto a high electrical voltage railing on the moon. People would direct their machinery to stay away from it because it was something that's dangerous, like a high voltage line on Earth. People don't play with them.
They do get tangled up in them.
There sometimes is a problem, like when there's a storm or a tornado.
Just last week, a guy got pulled off a rail.
And a subway.
Yeah.
Did he survive?
Yes. The guy that rescued him was a hero.
All right. Well, I'm glad for that.
600 volts, though.
Well, that'll do it. Anybody else got any questions for Fred? I think it's a great idea. I think keep pursuing it, Fred, and hopefully we can get some people interested to actually do some real trade studies on it and at least see, you know, the possibilities.
Well, the idea is on YouTube. It should live forever.
Well, it will, but you know, there's a lot of good ideas out there that just don't get any traction. So we got to make sure that this keeps plugging along, because it definitely goes against the current paradigm, which I like.
It does, and it also goes against the political idea to not spend any more on anything that they're not already doing.
Yeah, that's true. So it's an uphill battle, but I like that. So definitely a good presentation. Very interesting.
Well, thank you, Ben.
Yep. Anybody else got anything? Otherwise, I'll wrap this up. Okay. Well, thanks everybody for attending and for attending past Mare Cognitum meetings. Hopefully somebody will come along who will pick it up, and we'll have more of these at some point in the future.
Thank you for all you did, Ben.
Thanks, Irving. Appreciate it.
Thanks, everybody. Have a nice evening. That's it.
Yep.
Bye.
Thanks. All right, everybody. Have a good evening.